Alright, so I'm going to start you off and give you two basic functions here. And we're going to say f of x is equal to x squared, and g of x is equal to the square root of x. Alright, how do we verify that these two functions are indeed inverses of each other? From that example that we just sort of saw what an inverse function can do. Alright, here's how you do it. You have to check two things. You have to check that f of g of x will give you back the identity x. And you also have to check that g of f of x will also give you back the identity x. You got to check both of these things. So let's go ahead and do it one at a time. So f of g of x literally means take f and evaluate it for g of x. Well, g of x is the square root of x. So that means I'm going to take the square root of x and then run it through f function, which means I'm supposed to square it. Well, we know that anything square root of something squared just gives us back x, which is the identity function, which is what we were looking for. That's good news. Does that work for the other way around? Well, this means g of x squared, which means I'm going to have the square root of x squared, yep, looking good, equal to x. So we have now verified that g of x is the inverse to f of x. And what we have a special name for g of x, now we just call it this, f inverse of x. Yeah, you are doing inverses operations. So this is f inverse of x, is how we say that in mathematical terms. Alright, here's the two functions that we're going to, the functions there. So I'm going to give you f of x is equal to 3x plus 2. And g of x is equal to x minus 2 all divided by 3. Alright, so how do we show that g is indeed the inverse of f? Well, again, we got to check two things. Let's check that f of g of x gives us back x. And at the same time, let's check g of f of x and make sure that also gives us back x. So this is going to be f of x minus 2 over 3, which is equal to 3 times x minus 2 over 3, and then plus 2. Does everybody see how I'm plugging this in? I'm plugging this in for this x right here, because that's what f of whatever that stuff is. Does that make sense? Ethan, you with me on that part? Yeah? Alright, so that means the 3's cancel out with this part, and I am left with x minus 2 plus 2. Hey, check that out. Awesome. Gives me back x. That's exactly what I was looking for. Alright? But we also have to check to make sure that g of f of x gives us back the identity x as well. So we're going to say g of f of x is 3x plus 2. So now I'm going to take all of this information and I'm going to substitute it into my g function right there for x. So that's going to give me 3x plus 2 and then a minus 2 all divided by 3. Well, that gives me just 3x plus 2 minus 2. That goes away over 3. Oh, check it out. I get an x. I've now shown that each of these give me back the identity function, so g of x is indeed equal to... Okay, so let's start with this one. F of x is x plus 7 all divided by 4. And we wish to figure out what is the inverse function. So let's think about this mentally here for just a second, all right? Let's say, what is f of 1? What is it? What would I do? Yeah, I'd plug in a 1 for x. So I'd have 1, right? And then my next step is then I would add 7. You guys agree with that? And then the next step I would divide by what? By divide by 4. Now if I want the inverse to this, if these are my 3 steps, step 1, step 2, and step 3, then I want to go in the opposite order and I want to do opposite stuff. Right? So what's the opposite of divide by 4? So I'm going to multiply by 4. So I'm going to take a number. I'm going to multiply by 4. Okay, then what am I going to do? Instead of adding 7, what am I going to do? I'm going to subtract 7. So if I take any number x, and then I multiply it by 4 and I subtract 7, hey, it looks like I just found the inverse to that. Crazy, huh? No, check it out. If I plug a 1 into this, plug a 1 into here, what do I get? 8 divided by 4 is how much? 2. So take 1, plug it into f of x, out pops a 2. So I'm going to take a 2, plug it into this, and out should pop a 1. Does it? It sure does, right? 2 times 4 is 8. 8 minus 7 is 1. Yep, definitely. So that's the kind of like the mental way. Let's talk about the algorithmic way. Or the algebra way if you want. So we started with this. F of x equals x plus 7 all divided by 4. Okay, here's sort of the basic steps that you'll see in any book. First thing they'll tell you to do is replace f of x with y. So y equals x plus 7 all divided by 4. The second thing they'll tell you to do is switch x and y. So x equals y plus 7 all divided by 4. And the third thing they'll tell you to do is to solve this thing for y. So solve this example for, or this equation for y. So if I do that, here's what I get. Exactly, the mental way. Doing opposite stuff in opposite order. That makes way more sense to me than this algorithmic way. But I'll show you both. So if I want to resolve this thing for y, I'm going to multiply both sides by 4. And I'm going to get 4x is equal to y plus 7. And then I'll subtract 7 both sides. Hey, check it out. 4x minus 7 is equal to y. Isn't that what we got before? Oh yeah, it's right there. Right? 4x minus 7. But the last step that they'll tell you to do is that replace y with f inverse of x is now equal to 4x minus is equal to x. If we want to check this out to make sure that what we got down there was right, we have to say, well, we got to make sure that when we do f inverse of f of x, we get x back. So it's going to be f inverse of f of x was x plus 7 over 4. And that's going to be 4 times x plus 7 over 4 minus 7. Because that's what my inverse function is down there. So check it out. 4's go away. Leave me with x plus 7 minus 7, which leave me with x. I'll trust that you guys will check f times f inverse of x on your own. And you'll see that you'll also get that as well. All right, so here we need some help. Here we go. Okay, I'm going to show you right now. Here's the deal. So here's our function, and we want to try to figure out what the inverse function is, and we're going to use the steps to do it. And then our little test point is this. So if we figure out that f of 1 is equal to 9, so that means whatever function we come up with for our inverse function, f inverse of 9 should give us back a 1. So first thing we're going to do is we're going to say y is equal to 5 divided by x and then plus 4. I think everybody got there. That's no problem. Then we're going to switch the x and the y. So x is equal to 5 divided by y plus 4. Again, still no problems here. Then we're going to subtract 4. X minus 4 is equal to 5 over y. Now from here, people do all kinds of funky things, but they don't realize that if x minus 4 is an entire number equals 5 over y, then y is just equal to 5 divided by x minus 4, and you have solved for it. Now here's what people do. They get mixed up here. So a lot of people do this. They multiply by what, 1/5, right, on both sides?
No, you would do y over 5.
You want to multiply by y over 5 on both sides? Nah, most people do this. They'll multiply by 1/5, and they'll say 1 over y is equal to x minus 4 over 5. But that's not solving for y. Then that means that y is equal to 5 over x minus 4, which is the exact same thing that I got over there. So our inverse function, f inverse of x, should be 5 divided by x minus 4. And to check it, if I plug in f inverse of 9, do I get a 1 back? That's the question. So plug in a 9 real quick here. I get 5 over 9 minus 4. That's 5 over 5. That's 1. Yep, I do get it back. Dang. Recall something. Okay. For the fifth box here, have you remember what is the VLT? Vertical line test. That's right. And what does it tell you if it passes the vertical line test? If it passes, very good, then your graph f of x is a function. Okay. Have you guys ever heard of this? The HLT? What is that? Yeah, very good. Now, what does that tell you? What's that? Yeah, one-to-one function. Very good. So if it passes that, that means that f inverse exists and is a function. We call those one-to-one. One-to-one functions. So there is something called a horizontal line test, and if that horizontal line test is also, if it passes that, then it has an inverse, and if the inverse is also a function, then that's called a very special type of function, and we call those one-to-one. So let me give you an example of this type really quickly here. So one of them, right, I'll give you one that is and one that isn't.
Wait, can you explain that again?
Yeah. Yeah. Well, that's not the one I want. Yep. All right, let's take a look at this parabola here, right? All right. Okay, does this function here, this is a graph of y equals x squared. All right, is this a one-to-one function? No, it's not. Okay, first of all, it's a regular function because it passes the vertical line test, right? However, it does not pass the horizontal line test, so therefore it's not a one-to-one function, right? So it might have an inverse. The inverse would look something like this, but its inverse is not also a function. So it's not going to be a one-to-one function. So yeah, it's got to pass both tests. Yeah, exactly. So let me give you an example of one that is a one-to-one function, and that would be something that looks like this. So the classic example that you see in everywhere is y equals x cubed. All right, I'll just do it over here on this page. So does this graph right here, does this pass the vertical line test? Yeah, so that tells you that it's definitely a function, right? Does it pass the horizontal line test? It does, so that means this is a one-to-one function. So what that means is that its inverse function, which happens to be just the cube root of x, right, is also a function, and the inverse exists. So that makes it one-to-one. So do you see the difference here? So check it out. The red graph is f of x. The blue graph is f inverse of x. And because the blue graph is also a function, then that means that x cubed is what we call a one-to-one function. All right? Looks kind of nice, like a cool little knot tie in there, right? Looks like glasses. There you go. Okay? Now this leads us into our very last concept for what we're doing for the end of the day here. Okay, and the last thing that we're going to talk about for the last one is how to graph functions. How to graph functions and its inverse. All right? And what I want you to do is take out your calculators. We're going to use this one here. And we're going to graph the function that we did way back in box number 3, I think it was. We're going to graph these two functions together. Yep. 4x minus 7. And then the inverse function was x minus 7 plus 4. So if you hit zoom 6. Well, just zoom 6 puts us all back on the same page, so we're looking at the same thing. All right, so I'm going to graph it over here. I think I already have. There we go. There we go. So it was, what was it, 4x plus 7, yeah? Is that one of them? Okay, good. Was it minus 7? Is it minus 7? That's right. Minus 7. There we go. Is that right? What was the other one that we had? Okay. All right, so taking a look. All right, so this function I have here, this 4x minus 7, is that a 1-to-1 function? Yeah, it sure is, right? Because it passes the vertical line test, passes the horizontal line test. Okay, if I put this one on here, so do you see these two graphs on your screen? All right, so here's what I want you to take a look at. Do you guys notice anything special about these two graphs right here? Is there anything that you're noticing? Yeah, Jonathan, what do you notice?
They look like the other one is a reflection over the line y.
Yeah, he says it looks like they're a reflection of line y equals x. So let me expand on what he's talking about here. So what would be the coordinates for that point right there? -7, comma, negative, wait, holy cow. Tap delete. -7, comma, 0. You guys agree with that? Okay, now, what are the coordinates for this point right here, the inverse function? 7, comma, 0. Okay? What? Or, jeez Louise, I'm having a tough time. It's the end of the day. I know, it happens. Go away. Okay, sorry. So instead of here, I had 0, comma, -7. What about this point over here? What would be this one? Right there. What do you guys think? -3, comma, 1. What happens if I just reverse the x and the y? What do I get? I get 1, comma, -3. Is that point on the graph? Okay, is this true for all the points then? Okay, good. What is then so important about this line right here? Y equals x. Yeah, very good. So I'll put that on the graph right there. Check it out. That is the line that the inverse function is being reflected over, right? Okay, so here's what I want us to do for the last part here, for this one over here. Give yourself a coordinate plane, like a 10 by 10 coordinate plane here. Or we'll just go that far. Okay, and we'll give ourselves a pretty easy function to work with. We'll give ourselves this one here, that one, and then finally that one over there. Okay, so we'll go up, and we'll go down. And I'm going to call this little function here, I'm going to call this f of x. And we're going to figure out the domain for f of x. And we're going to figure out the range for f of x. Okay, so look at this picture here. What will be the domain? From where to where? Where does it live? Yeah, so all round numbers x such that -4 less than or equal to x less than or equal to +4. Good. What about the range for this one? All real y such that -1 less than or equal to y less than or equal to 2. Good. Okay, good. Now, we want to graph the inverse function. So I'm going to do that in a different column. Do it in red. The range, because it goes from -1 up to 2? The y values? So instead of this point here being -4, comma, -1, I'm going to reverse the x and the y. So I'm going to have, instead I'm going to have -1, comma, -4. -1, wait, holy cow. Yeah, -1, -4. I'll get there. All right, what is this coordinate point over here? -1, comma, 2, right? So we're going to flip the x and the y, and we're going to have 2, comma, -1. And then instead this coordinate over here, which is 4, comma, 1, we're going to flip that and we're going to have 1, comma, 4. 1, comma, 4, which will put us right here. And then I'll draw in the graph for this right there. And notice that if I were to reflect this line over the line y equals x, I'd have the inverse function. Now, is this necessarily a one-to-one function? No, because it doesn't pass the horizontal line test. But it does have an inverse, right? But it's not one-to-one. But here's the cool part. What is your domain for f inverse of x? Yeah, very good. It's the range of f of x. The domain goes from all real numbers x such that -1 is less than or equal to x, less than or equal to 2. Which you'll notice is the exact same thing as the range of the regular function. So has there ever been a time earlier today where we just flipped the x and the y? Yeah, when we're algebraically finding those inverse functions, right? So, doesn't it make sense that the domain of the inverse function is the range of the regular function and vice versa, right? So what's the range of your inverse function? It goes from where to where? There, yep, less than or than +4, which is the domain of the regular function.